Hello, welcome to Meki Techie. Learn as engineer, teach as champion. First of all, I would like to thank my family for their continuous support and encouragement of creating these kinds of technical videos in public domain. And I would like to thank my mentor, Professor R. Surendran from Government College of Technology, Coimbatore, igniting me a spark of creating these kinds of technical videos in public domain. And I would like to thank Almighty my God for my good health and broad mind. And I would like to thank my friends, followers, my dear students and subscribers for their continuous support and encouragement of creating each and every video and commenting in all. Today's topic of interest is drilling. Drilling is a hole making process. We are having a flat component like this, or if we want to make a hole, if we want to produce a hole, for this process for this process the drilling is very useful. So this process is called as drilling. Drilling is a hole making process. Simply we can say it is a hole making process. So in drilling, we have different types of drilling machines and different types of drill bits are used for making hole. Here, one thing you have to understand that the drilling tool we are having 2 points. Okay, one is this is a drilling tool is a multi-point cutting tool, and the action of material removal is oblique. So these 2 points you have to remember. And with this information, I would like to go with the drilling which I have taken the points. First, we are going to discuss about drill tools, drill bits. First, it is a twist drill. The twist drill, mostly the drill bits are made up of high speed steel, HSS we can say, and this body and shank of the drill bit is welded by means of a friction welding. Body and shank are tapered. Both are having tapered ends at the end point of the part in twist drill. And this is having the end point and this part in twist drill. Next one is a gun drill. In gun drill, straight flute drills are used. It is having zero rack angle, zero helix angle. Therefore, the gun drills are used for drilling very brittle surfaces like a concrete. Concrete can be drilled by means of a gun drill. Gun drill is a portable drilling machine too. In the gun drill, it is having portable drilling. Therefore, in each and every walls, if we want to drill anything, we can drill by means of a gun drill. Next one is a core drill. Here in the core drill, we are having three or more flutes are there. This is for re-drilling the purpose. If we want to make, for an example, 50 diameter drill in a block, we are having a block of dimension like this. So here we want to produce a 50 diameter hole. We are having 50 diameter drill, but assume that this area 50 diameter, the how much force is required to drill. You have to assume that how much material is removed. So it is huge. If you assume that if it is huge, therefore it is not at all possible for making a large number of large drill by means of a drilling machine. That is why we are putting, first we are putting 10 drill, after that 25 30 drill, after that the 50 drill. Like that, different radius or different diameters of drills are used. So for initial purpose, maybe twist drill is used, and re-drilling purpose, the re-drills are called as a core drills. So this is core drills is mainly for re-drilling purpose, re-drilling of holes or enlarging the holes. And core drill is different and boring is different. Boring and reaming both are different. Okay, that you have to understand. Next, these two things you have to understand that for drilling soft material, for drilling soft material, the drilled using low helix angle, and for higher helix angle can cut more metals. Higher helix angle can cut more metals. Therefore, for the soft material, the low helix is preferred because since the material is soft, if we use a large or higher helix angle, it remove or it enlarges the predefined hole. That is why the soft drill is being used. Here, one thing you have to understand, the point angle of every drill bit is 1118 degree. If our drill bit is for the harder material, this point angle may vary, it may go up to 135 degrees. Okay, 1118 to 135 degrees. For a soft material, generally it is less than 1118 degrees. That is why it is called as a low helix angle. For ferrous materials, this helix angle is 30 degree and point angle is 18 degree and lip angle is 60 to 80 degree. Here I have given the point angle and helix angle for different materials. First, the point angle for drilling marble is 80 degree. For bakelite or phenol formaldehyd it is for 90 degree. Hard nickel alloys it is 135 degree, and soft materials is less than 118 degree, and hard material it is more than 118 degree. And helix angle for harder material it is 10 to 15 degree. Fast helix drill it is 35 degree. For aluminum, for drilling aluminum, zinc, magnesium it is very much high. For brass and bronze bakelite it is low, and generally ferrous materials it is up to 30 degree. Next one is the reaming. Reamer, it is a multi-point cutting tool which is very similar to drilling process, where in the drilling the helical tooth profile are used, whereas in the reamer no helix angle is used. The straight fluted multi-point cutting tool is used. It is to improve the surface finish and dimensional accuracy of a already drilled hole. The already drilled hole can be better surface finish by means of a reamer, can be produced better surface finish by means of a reamer. Next one is the tap drill. So before making a internal thread, this tap drill is used to drill a hole before making internal threads. So that is the function of tap drill. And next we have a small formula point of view for drilling a diameter and drill speed. Here the drill speed, drill velocity, we know that pi dn by 6, pi dn by 1000. Since the 1000 is for a drill diameter in millimeter is converted into meter, or otherwise velocity we know the formula pi dn by 60. If it is for if the speed is meter per second, or if we want to produce meter per second, we have to divide 60, or we don't need to change this minute to second. We can simply put pi dn is enough, where d is the diameter, it should be multiplied in terms of a meter. Okay, and v is the drill cutting speed meter per minute, and n is the rotational speed, where feed rate Fr is equal to F into N, where F is the feed and n is the RPM speed. The machining time T is equal to T plus A divided by FR. FR is the feed rate, T is the thickness of the workpiece, A is the approach allowance. Here I have given an approach allowance. Approach is equal to over travel plus approach allowance. So that is the allowances. Next, material removal rate MRR is equal to area into force. Here we are neglecting the allowances. So area into feed rate. Sorry, if not it is a force, it is a feed rate. It is supposed to be a feed rate. Area into feed rate. How much area is removed in every feed, that is the important. Next is the drilling machine design. In drilling machine design, the torque conversion as well as the speed conversion is very much important. This thing we have to say in terms of a geometric progression, where geometric progression is equal to r power n minus 1, that is equal to maximum speed divided by minimum speed. We know that the maximum speed is for motor and minimum speed is for the drill gun. Therefore, the geometric progression can be calculated by means of n max by n minimum. Here, for an example, we are having 5 stage speed reduction. If the small n is equal to 5, therefore geometrical progression of the rest of the 4 speed ratios are r power 4 is equal to the maximum speed is n5 divided by minimum speed is n1. Therefore, this is the formula to find geometric progression. Next is the counterbore drill. In the counterbore drill, we are going to enlarge the hole up to certain depth in order to accommodate the bolt heads. We are going to drill a certain large diameter hole up to certain depth. So here we know that, so this is our workpiece. So here this is the hole. So this is the hole. In order to accommodate the bolt head, we are drill the hole like this. Here the bolt heads are been seated. So this is called as a counter boring, and the counter sunk is, if this is our workpiece, so this is our drill, we are just tapering the head in order to get taper screw threads. If there is a screw thread, the screw head should be seated in this manner. Like that, the process of counter sunk is being used to enlarge the hole up to certain depth in taper way for seating of screw threads. Next is a trepanning. Trepanning is an interesting phenomena. Here in the trepanning process, we are going to use a single point cutting tool. Without the core drills, we can produce a huge diameter of the drill can be produced by means of a trepanning tool. To produce large size hole by removing a disc shaped piece from the workpiece. A disc shaped piece. When we are seeing a fall ceilings, we want to accommodate a light on the ceiling. What we can do, we are using a single point drill and we cut a big disc type of shape, and those disc type shape can be removed by means of a trepanning tool. Next is a boring. Boring operation is for enlarging the hole, and here also the single point cutting tool is being used. For boring and trepanning in the drilling machine process, we are using single point cutting tool. And the purpose of helical groove in the twist drill is, first thing, if we want to provide a space for chip removal, we have to provide rack angle for cutting edge. So these are all the two purpose of the helical grooves in the drill. Like that, if we want to supply coolant till the lip point, we can use this helical grooves. In the helical grooves only the chips are being removed. Like that, we have different purpose for the helical grooves. So with this, I'm going to stop the drilling content. So I hope that I have given an enough content to you. If you have any doubt, you can comment me, and I will definitely I will put in another video for your betterment of understanding about the mechanical processes. Until bye bye from Santosh. Thank you all.